Here in this video, we are talking about the magnitude of the heat radiation, how much of the heat radiation happens, basing on a law called Stephen's law. According to Stephen's law, according to Stephen's law, the heat energy emitted by a body in the format of radiation per unit surface area per unit time is directly proportional to fourth power of absolute temperature. Be careful. This temperature must be absolute temperature. That means what we shall convert that into Kelvin. Thus, energy emitted by a body per unit surface area per unit time. Proportionality can be eliminated with a constant sigma, where the sigma is called as Stephen's constant. You can write its units and dimensions, but anyway, let me write its numerical value in SI system is 5.67 into 10 power minus 8 in SI system. I will write what is the unit of that SI system, but for a while, let's remember this value, that Stephen's constant is this much. So if you are interested in writing what are the units of that sigma, you can write energy emitted by a body per unit surface area per unit time by fourth power of absolute temperature is sigma. Right? So what is its units is energy is measured in a unit called joule. Area is measured in a unit called meter square in SI system. Time in seconds, temperature is Kelvin, power of 4 is there. So its units are joule, meter power minus 2, second power minus 1, Kelvin power minus 4. So its value in the SI system is, as I told you, 5.67 into 10 power minus 8, and the SI units are this, whatever may be the value is. You can also write its dimensional formula, right? If you want to write its dimensional formula, sigma is energy. You know the dimensions of energy is ml square t power minus 2 by area square of length, time means t, and temperature is k power 4. So what its dimensions is, this L square and L square can be cancelled, m t power minus 2 k power minus 4, t power minus 2, and of course there is another t is there, so that becomes t power minus 3 and k power minus 4. That's what the Stephen's law is. So Stephen's law says that energy emitted by a body per unit surface area per unit time is directly proportional to fourth power of absolute temperature. But this law has a little flaw. What is that flaw is, this says that body will be keep on emitting energy until it is having a temperature. But there is an, if a body emits heat or not simply depends on if the temperature of the body is more than the temperature of surroundings. What happens if temperature of the body is equal to temperature of surroundings? They both comes into thermal equilibrium. Then there is no emission of heat. Then there is no emission of heat radiation. So heat radiation is possible provided the temperature of the body is more than the temperature of surroundings. That aspect is missed in this Stephen's law. That is later observed by Boltzmann. So the Boltzmann has made a correction. That correction is called Boltzmann correction, or the new law could be called Stephen's Boltzmann's law. What is that law says is everything is same. Energy emitted by a body per unit surface area per unit time is directly proportional to fourth power of absolute temperature, provided temperature of the body is more than the temperature of surroundings. To add that, this minus temperature of surroundings power 4 is added. So now it will happen gel very well that if temperature of the body equal to temperature of surroundings, the RHS becomes 0, then there is no emission of heat radiation. That is very well explained. That's correction is made by Boltzmann. That's why this correction is called Stephens-Boltzmann's correction. Then you can write energy emitted by a body per unit surface area per unit time. Proportionality constant remains same, that is Stephens constant. Temperature of the body power 4 minus temperature of surroundings power 4. So if you want to calculate only energy emitted, I can take this area and time to that side, that is sigma area into time. Temperature of the body power 4 minus temperature of surroundings power 4. In writing all this, we have assumed that body is a perfect black body. Means what? It emits all the heat radiations that it has. But body is something that can sometimes contain some of the heat for itself depending on its nature of emission, right? To study that, we have defined a term called emissivity. So emissivity is something like the ratio of heat emitted by a body when compared with the heat emitted by a perfect black body. If suppose this body is also a perfect black body, the heat emitted by the body is equal to the heat emitted by the perfect black body, then the value of that emissivity becomes 1. So for a perfect black body, emissivity is equal to 1. But I can write then say in general, we can write that implies in general, we can write Stephens-Boltzmann's law as energy emitted by a body per unit surface area per unit time is sigma. We shall multiply with a term E which is called as emissivity. That is the ratio of heat emitted by a body when compared with the heat emitted by perfect black body. It's a ratio of similar physical quantities, so it has no units. Its best value equal to 1. For a perfect black body, E value is equal to 1. E value equal to 1 for whom? For a perfect black body. For any black body, it is greater than 0 for any body in general. For any regular body, E is greater than 0. It cannot be 0 because there is no body that cannot emit some radiations. It will definitely emit some radiations. And it is of course less than 1 for a normal body. So E value is in between 0 to 1. So whatever the body E value, if something is given for you, you can substitute. But be careful in understanding one point that in any problem, if emissivity is not given, you assume that the body is a perfect black body and E value equal to 1. So we can assume that and take this value as 1 and you can forget about E and solve the problem like a normal scenario itself, right? That's what Stephens-Boltzmann's law is. Or finally, be careful that we shall have a term emissivity also. Many times people don't give that emissivity and we take it 1. We assume that the body is a perfect black body. That's it. Thank you for watching.